Welcome to the Dusty Jobs podcast from Imperial Systems. Industry knowledge to make your job easier and safer.
Good afternoon and welcome to Imperial Systems podcast. We're here again and we're just glad to have Chris Phillip with us from AKS. How you doing today, Chris?
Good. I'm doing well. Drove in this morning from just north of here and had a nice little factory tour, and it's just a good day. It's finally somewhat springy out. So
yeah, the weather's nice weather day today. So you have, we've been working with you guys on different products for how many years now with AKS?
Probably, since really your inception in the dust collection and plasma, I believe.
Yeah.
So 4 or 5 years now at least.
We've had a good long relationship,
yeah.
I would say. So, but for all of everybody out there listening who doesn't know who you are or who AKS is, how about you give us a little bit of background on your company, on yourself? Let's start out with you. Tell us about yourself first, and then tell us about AKS.
Sure. So I'm Chris Phillip. I'm one of the regional sales managers for AKS Cutting Systems. And my territory is Eastern PA, so starting at State College going east, Maryland up to Maine and New York State.
Yeah.
And in that territory, I manage somewhere around, on a good day, 7 or 8 dealers, on a bad day, 3 or 4 dealers, depending on who's doing their job that day. And that's what I do. I drive around. I live in Cleveland, Ohio, right about 12 minutes from our factory.
Yeah.
And I drive around and fly around and go meet new people who want to get into the world of plasma cutting or want to get into the world of laser cutting and really need a plasma table, or people who want to get a water jet as well. That's also a world that I dabble in as well. AKS has been around now for, 120 years.
Wow.
It's actually my great-grandfather purchased the business in the late 40s, I think is the most accurate story that I've heard so far.
Okay.
And my grandfather, Dale Phillip, ran the business for 50 years. Maybe a little longer than that, somewhere around there. And my dad, 3-4 years ago, took over the president's seat. My grandfather is still the CEO of the company.
Yeah.
And I got out of that office as fast as possible and on the road. I wouldn't trade it for the world. I love being on the road.
But you could say plasma's in your blood almost.
Honestly, yeah.
Not technically, not actually.
No, actually, technically you can.
That's true.
Yeah, there's plasma in your blood. You need it there. Yeah. That's actually a great, really random little story. When my grandfather first got into the plasma industry, a guy called him out of Luxembourg or something, somewhere, Switzerland or something. And he said, hey, have you ever worked with plasma before? And we made automotive assembly lines. We made gauges to measure distribution caps for airbag deployment. We made gauges for nuclear rod insertion systems, making high-speed battery assembly line. We were all over the place. Yeah. Loading torpedoes with liquid helium.
Oh, wow.
All sorts of random stuff. We were the essence of a job shop.
Yeah.
And the guy called him and said, hey, have you ever done anything with plasma? And this is like in the early 80s.
Right.
And so my grandfather says, no, we don't do anything in the medical business.
Yeah.
He didn't even know that plasma was a thing that you could cut with.
Right.
Obviously now everybody knows that plasma is one of the 3 main technologies that you use to cut steel and stainless steel and aluminum plate. And, when we started in this 35 years ago now.
Yeah.
We had no idea what we were doing.
Right. So, but 35 years ago you guys were probably one of the first ones in the States to be using this technology.
Definitely. We were actually exporting them to Europe because for some reason, the European marketplace started using CNC cutting technology. It seems, at least to me, a little bit quicker than the United States steel processing centers. And now it's everywhere. Now we have over 1,500 installations.
Gotcha.
And we make 120 machines a year.
Now, when you say 120 machines, are we talking about, because you guys carry a variety of different types of machines, correct? When you're talking total machines, are we talking about just plasma tables? What are we talking about?
Total machines.
Yeah,
total machines. For every 5 plasma tables we sell,
right,
we sell about 1 water jet, which is in line with the market distribution as well. When you look at how many water jets are sold nationally and how many plasma tables are sold nationally,
right,
that's about the ratio as well.
Gotcha. So kind of like your grandfather, when I see a plasma table working, I am like, how does this thing even do what it's doing? It's interesting to watch it cut, and you're like, what is going on here? Now, can you tell us, for people who are a little bit ignorant like me, what is the actual technology, or how is that? What's it doing there?
No, I can't. Because even after doing this, living in it, I'm still pretty amazed by it every day that I see it. I can give you a rough metaphor of what it's doing.
Sure.
So there's you're taking a tremendous amount of energy. Usually it's 480 volt 3-phase.
Okay.
67 amps. So a lot of power.
Yeah.
Maybe 70 kW
Okay.
of power into this system. So you think your lasers in the world. You get a 10 kW laser. Wow, that's big time.
Yeah.
That's big time. You're cutting 1/2 inch plate.
Right.
We're taking 7 times that, and we're putting it into an area about this big, maybe 1/8 of an inch big. And how it gets there is kind of interesting, though. So you get this 3 waveform electricity, AC electricity coming into your shop. It's going like this through the air. And there's this device called a chopper. And it's actually a really old piece of technology, but because of the power levels that you're dealing with, you got to use them. They're
Okay.
the only thing that's robust enough to deal with this. And what the chopper does, kind of like what your power supply on your laptop does,
Yeah.
it takes that AC power and turns it into DC.
Oh.
And so it actually chops up those waveforms. That's why it's called a chopper.
Yeah.
And it makes it into a nice positive line, hopefully. That's the idea, unless you got dirty power. But that's a separate conversation. And we then take that and we somehow, it gets from the power supply, the big black box that Hypertherm makes, and that box is 80% chopper, right? That's the big thing that you're buying in there.
Yeah.
And then a lot of oscilloscopes and other pieces of technology that make sure that line is as straight as it can be.
So 80% chopper, 20% magic.
Yep.
Yeah, so-
somewhere 2025, maybe it's over 100%.
Okay.
I'm not sure, but it's a lot. And then that goes into the torch body, and I'm definitely cutting out a lot of parts here, but there's high frequency stuff that's going on, and it gets to the torch body, and it gets to the nozzle, to the electrode, and that electrode is going to then, that's where that's basically I believe it's the cathode in this relationship.
Okay.
And it's going to start arcing back and forth, and then you run a gas through it, and that gas turns into plasma. So
okay.
plasma is the 4th state of matter.
I gotcha.
Right?
Yep.
So that gas is, you got solid, liquid, gas, plasma. When you super excite a gas with electricity, 60,000 watts of electricity
Right.
in an area this big, that's a way to get that going. You do that and then run a gas through it at a high pressure. That gas actually becomes magnetic as it turns into a plasma.
Okay.
And that wants to then grab something, right? It's magnetic. And
Right.
so it grabs the steel plate that's right below it.
Okay.
And when it hits that steel plate, that 70,000 watts of power is also about the surface temperature of the sun.
Wow.
So it doesn't just melt it, it actually ionizes the material.
Oh.
It changes state again and turns it basically into electricity.
Wow.
At least a small portion of that material.
Right.
Most of it gets melted.
Yeah.
And then you have a 115 psi assist gas that comes out that then actually blows the material out of the way.
Gotcha.
And that's basically the gist of how plasma works. We're taking super high voltage electricity,
Uh-huh.
arcing it,
Yep.
running a gas through it, and then letting it do its thing.
Gotcha. And that in a controlled pattern.
As
too.
controlled as we can get. Yeah.
Yeah.
And that's the part that people always want to know. They say, okay, so what's the accuracy of your plasma table? They got 3 machining centers. What's the accuracy of your plasma table? Can it hold 5 tenths? Can it hold 10 tenths? And the answer is, well, imagine you're trying to hold a candle and you want to know where that flame is.
Yeah.
It's really, really hard.
Yeah.
There's ways to do it. You can measure it, but it's tricky.
Right.
It's tricky.
Right.
And obviously, just like a candle, one of the byproducts of having that flame is a lot of dust,
Well, yeah.
which takes us to the reason why we're here on the Imperial podcast.
That's where we step in and start helping out with that.
Yeah.
Now, from my base knowledge on plasma tables, and boy, I have a lot more now from just that
It's all
conversation.
wrong. It's all wrong. Any service technicians that are listening right now, just close your ears to that last 5 minutes because it's going to hurt.
But so as that chemical process is happening, that's allowing that to cut that metal. There's obviously some byproducts, and that's what we're talking about. There's smoke,
Yep.
and from what I understand, there's two ways that basically the industry uses to capture that. That's a bed of water underneath it,
Yep.
or actual sucking that smoke down through the table. Am I getting anything wrong here?
No, that's the two methods that I know of.
Okay.
The third method is you just don't care enough and you let it fill up your shop.
And
Which
I'm sure you've been in some shops where either the collector's
it's
not
interesting.
working. Yeah.
Yeah, you don't want to be in those for too long.
I know we had one time out here where we had for some reason when someone changed the filters in our own collector, they forgot to engage them so that they were actually uptight, and we had some blow through on our plasma smoke. And very quickly, we knew in our shop, as everything started to turn orange,
Yep.
that we had done something wrong.
Yep. Well, you guys cut a lot of mild steel, so that definitely makes sense. It's interesting. You can actually tell what product you're cutting, what material you're cutting, based on the color of the smoke.
Ah.
Right.
Okay.
So your aluminums, it's going to be like a whiter smoke.
Okay.
Right? And on your mild steels, your carbon-based steels,
Right.
it's orange. Because what is burning metal? We all know what a burning metal really is. It's oxidation.
Yeah.
It's extremely accelerated oxidation.
Yeah.
So what you got there, the byproduct of cutting this material, along with the slag that falls off and the part that's made, and that stuff that isn't there had to go somewhere.
Right.
I know there's a lot of magic in the box, but there's not much magic on the table. That's pretty simple. And the answer to that is it oxidizes and it becomes that smoke. And the reason why it looks all orange is it's rust.
Right.
It's rust. It's rust flakes that are flying everywhere through the air.
Yeah.
And they're just a lot smaller than what you consider rust.
Yeah. Yeah. That makes a lot of sense. So when we're talking about the water-based tables and we're talking about the air-based tables, can you kind of tell us a little bit? I mean, I'm sure each one has some advantages, some disadvantages. Can you tell us a little bit more, unpack?
Sure.
If someone's listening to this or trying to decide, should I get a water-based table? Should I get an air-based table? What would be some things they should think about?
Yep. Well, I'll prep that question by saying I am, and this is no accolade to Imperial. I'm 100% downdraft.
Gotcha.
100% downdraft. And the reason being is because of that idea that we started with this conversation, the controlling the candle.
Right.
We figured out that you can just have a candle waving in the air.
Mm-hmm.
You can have a plasma torch that's just doing its thing, like we did back in the early 80s when we didn't really know what we were doing.
Right.
Since then, there's been all sorts of developments. There's the different PSI assist gas. You can take that candle flame, and if you run a high-speed current of air up the side of that candle,
Yeah.
guess what? You stabilize that candle flame, right? It's called a shield gas.
Okay.
Same thing that we do. We run a cut gas that actually gets electrified and turned into the plasma arc. Mm-hmm. And then there's also a gas on the outside of that, just like a welder does, that isolates that gas, the plasma arc, from ambient air. Because we don't really know what's in the ambient. There's a lot of nitrogen, there's other stuff, and who knows? And by doing that, by isolating that flame from atmosphere, you really improve the quality of your cutting.
Right. It gives it more of a controlled environment to live in. Yeah. Yeah. So you're saying on a downdraft table, then that helps assist with that. Is that right?
We're getting there.
Okay.
We're getting closer. So after they did those types of shield gas types things,
Okay.
they were still cutting plus or minus 20, 25 thousandths of an inch, maybe more than that, 50 thousandths of an inch.
Okay.
You think it's minuscule, but a human hair is about 5 thousandths of an inch.
Right.
So we're cutting hairs here, literally.
Yeah.
But that's what they were living at when they started doing that. And so they started looking at other variables. What else can we change? And at that point, basically everybody was using a water table. They were just looking, they just said it captures it, and it works. And somebody eventually had the idea of, well, we know that by cutting this, we're obviously causing a lot of thermal changes in the material, and maybe if that was more consistent, we would cut better. Meaning, why are we quenching the bottom of the plate in water,
yeah.
right? This is a thermal process. We're melting stuff.
Right.
What if we just let air, be underneath the plate? And that improved the quality of cutting. You don't get as much dross. When you cut the material, obviously some of it's liquid, and it's going to build on the bottom of the plate. And if you cool it right away, more of it's going to build on the bottom of the plate.
Yeah.
Makes sense, right?
Yep.
And also it just causes different thermal things to occur with the material. So in my experience across the board, if I want to show somebody a really good part, the system that we have in our facility,
Yeah.
when we cut samples for customers all day long,
Right.
it's a downdraft system, 110%. It would never be a water table.
I gotcha. Because you just get a little bit more of an accurate cut.
You get a better cut.
Ah, I gotcha.
And also when I've had this conversation, obviously, literally a couple hundred times with people trying to decide between a water table and a downdraft table. And I think one of the biggest, there's two huge factors in determining where a customer is actually going to end up
Okay.
between plasma and water jet. The first one is their space.
Okay.
Right? Huge. In the plasma world, the dust collector is honestly kind of seen as a pain. I got this big thing that I got to deal with.
Yeah.
It takes filters. I got to do stuff to it. And for some reason, a lot of these guys look at the water table and they say, "Oh, I just fill it up with a hose and it's good to go."
Yeah.
And then they're surprised when somebody knocks on their door and says, "Hey, have you bought your 500 gallons of plasma table additive to add to your water over every month to keep it from becoming a cesspool in the middle of your shop?"
Yeah.
And they go, "Whoa, what's this?"
Yeah.
So that's definitely a big thing, is people think that it's easier to have a water table. And right.
I think a lot of people don't, once the water's in there, it's hard to know what to do with it to get rid of it too. I know that's been, we've had some calls like that in our own facility, and we don't deal with that, so we're not really experts.
I was about to say, what would you say to that?
We say you have to contact someone else who's a hazardous waste manufacturer or
right
disposal.
Answer.
So we say we're not able to help you with that. Sorry. But if you want to get a downdraft table, we can help you know what to do with those filters when they're done. So, but so that's another question we usually get, is what to do with this water. And I
definitely,
the best answer I've come up with, I don't know if you know a better one, is just contact your local hazardous waste.
Yeah, you can actually
people.
Contact a sewer cleaning company.
Oh, okay.
And they'll bring in a pump truck, and they'll take a 8-inch hose that's set up on some diaphragm pump or something, and they'll take that 8-inch hose and suck out your whole table dry in about 45 seconds.
Gotcha.
As long as they can access the table. They
Yeah.
gotta be able to back a truck up through your shop. And that's usually the catching point, because if somebody buys a water table, one of the big reasons why they want to do that is space.
Right.
Right? First thing that one of the two big factors, space, and the other one actually I haven't gotten to. It's what they already have owned in the past. But usually if they're buying it, it's because they got piles of steel everywhere. There's 2 rolling machines in the way. There's a break and this, and there's no way they can get a truck to the table.
Yeah.
So they say, "That's great. What else?" And the answer to that is, well, buy yourself a little sump pump, put it in there, get a 55-gallon bucket, and start pumping that thing out and dumping it down the drain until you have a wet sludge of empty table.
Yeah.
And then you got to go in there, and maybe if you have a guy who might be on his way out the door or something, you tell him to go clean out the water table, because I wouldn't want to do it.
That's
you're just left with the gunk that's builds up in a table that's probably sat there for a year full of water, stagnant.
right.
All the dropouts and stuff, and it gets gross. But you can do it.
Right.
People do it all the time. That's what a lot of people still do it, and the reason why they still do it is that second reason. It's what they know.
Yeah.
A lot of people, if they had a water table, they're just going to get another water table.
Right.
They don't see the upfront cost of a dust collector is advantageous.
Right.
Because they're blind to the dross that they're dealing with, the extra rust that they're dealing with, all the extra stuff that the downdraft system helps alleviate those costs down the line.
Gotcha. Yeah. Yeah. If you don't know, you don't know.
Right.
Right. So, all right. So do you feel like we've covered everything with the downdraft table setup? So you know more than I do. If there's anything else out there that might be good for someone to know about that.
Yeah, I guess the only other thing that people definitely worry about with downdraft systems is the possibilities of explosions. And that's obviously a big thing, especially when you're cutting aluminum. Powdered aluminum is literally what's used to make military grade explosives. Right?
Yeah, right.
And so one of the byproducts of cutting aluminum on a table is powdered aluminum, basically.
Right.
It's the dust that's created from the cutting, that white dust. With your spark arrestor properly maintained and the systems that you guys have offered, we cannot say that with the couple hundred installations that we have that we've had an issue with the system being maintained and used how it should be.
Right.
That spark arrestor in particular is, I was just poking around, and if you haven't seen one on the inside, look it up. They got some good cross sections on Imperial's website. But that thing does a good job. You can't drop big drops into it. You got to clean it out once in a while.
Right.
And that can be hard to get people to accept once in a while. But if you maintain it, it shouldn't be an issue.
Yeah. And that's why we built the clean outdoor on it. So you can do that. You can inspect it. And everyone's inspection level is different and how often you need to do it. And some of that comes down to the operation. Sometimes that comes down to the operator who's running that piece of equipment. So, but you're right. It's good to poke your head into that every once in a while and make sure it's good, whether it's every 6 months. And we always, I'm sure you guys do too, we always try to encourage preventative maintenance on everything. And there's, that's with every piece of equipment you have in a shop. Anybody who's running a shop knows that. You gotta look at stuff every once in a while, right?
Yeah, definitely.
Okay, so wet versus dry. I think we got a really good feel for that, where we're at, what the industry's like. So I'm going to ask you a question, and I know you're not a doctor. I'm not a doctor, but one of the big questions we get, a lot of people looking up, is plasma smoke. What is the health implications for that? If I'm breathing that in, people get worried about that because.
Definitely.
Yeah, and I'm sure you've got to ask that question too. Being what you do for years and years and years, and I'd love to hear what your answer is on
that. Sure. So cutting stainless steel in particular is a known carcinogen.
Right.
That's something that is factually known. Right. Mm-hmm. You don't want to breathe in the dust that's created from cutting stainless steel. Mm-hmm. Hexochromium variant gas. That's the byproduct.
Okay.
And apparently that means it's bad for you.
The name is just scary itself. Yeah.
Aluminum, one of the byproducts of aluminum is hydrogen gas, which something I didn't touch on is with a water table, when you cut aluminum, you get hydrogen gas buildup under the plate.
Cool.
And that eventually will blow up. You're worried about your dust collector blowing up once every 15 years. If you don't have a properly maintained bubbler system inside of your water table, you could have an explosion once a week on that. And I actually saw one where a 1/4-inch plate of aluminum, they hit a pocket of hydrogen gas underneath it, and it looked like a tank round went through it.
Gotcha.
And it just boom, and that plate was, it hit the beam lifted up.
Wow.
It was a lot of, whoa, that was neat. And
we'll just pause here for a second on the dangers of smoke. And I want to talk about one thing. So even if you have a wet table,
mm-hmm.
are you saying that still doesn't collect everything that the byproducts are? Or are you saying you still might need a ventilation system on that? You've seen a lot more of these in the field. You're talking about it possibly could blow up. Is that something that even on a wet table you might still want to consider that? Or I'm going to let you speak to that.
Sure, definitely. So in an ideal setting, if you're using your water table properly,
okay,
meaning you're running your water about halfway up the side of your plate, it has an internal bladder system. So when you take your 1-inch plate of steel and you put it on it, it is up to the bottom of the plate. And that's really important. You can't have a gap.
Okay.
You can't have an air gap there, because if you have an air gap, all the smoke just goes out from underneath the plate and you might as well not have anything.
Right.
So you got to keep that water up. Well, by having that water up, then you deal with all the issues that the guys down the line don't want. That after the pain of a capital expense up front goes away, your production guys say, well, every part I get off this machine has dross on it. And there's flash rust on the bottom.
Yeah.
Lower the water. And so they lower the water just a little bit. Mm-hmm. And now their dust collection went down from 95% or so to like 10. But their parts turn out great.
Gotcha.
And they say, well, I have a water table, so let's just not worry about it. There's a lot less dross because you're not quenching the slag as it comes off the part. And you're running a current through steel in water. You get rust. Right. And you can flash rust a part in a couple seconds, especially when it's submerged in water.
I gotcha.
You can literally watch the rust grow on the piece of steel.
Wow.
It's kind of wild.
Yeah, that's crazy. So you're saying when people do that, when they drop that water level, then you still can.
Then they're just not even using the water table, right? They're just they have the water table, they're maintaining it, they're cleaning it, they're doing everything they need to do. They paid more for the water table,
right,
on the base system,
yeah,
than a downdraft system. At least the ones I sell, our downdraft tables are cheaper than our water tables.
Oh,
Yeah, kind of an interesting thing. But you still have smoke that gets out. And so now you're dealing with all of the negatives of the capital cost of the water table and very few of the positives,
yeah,
Yeah. So that's after, 6 months, you go back into a shop and sure enough, you see that they're running it below where they should.
yeah. But we'll just throw this out there. If that happens and you guys need some other type of collection system, I mean, Chris, definitely. You can definitely help them out with that.
100%.
Help them figure out a solution for that. So whether it's a hood, whether it's whatever. So we.
I liked your ambient system out there, honestly, in your factory.
Yeah,
that's a nice system.
It's
could
worked
see a
really
lot
well
of
for
shops.
us. Yeah, it's a good solution. So we've talked about that on a previous episode with Jeremiah. So if anybody's listening and they want to go back and look at industrial setups, that's one of the things you can go back to that podcast episode and listen to that. And Jeremiah can walk you through what an ambient system is. So, but all right. So the dangers of plasma. Now we're coming back around to what the health implications. So a lot of it comes down to what you're cutting, is what you're saying.
Yes. At the end of the day, I don't know if mild steel smoke is actually poisonous.
Yeah.
Like you said, we're not doctors.
Right.
But I've watched guys have to breathe it in, and it looks a lot like welding fumes.
Yeah.
And it doesn't look nice. And I've watched, you can be around a plasma table and watch it cut 1-inch plate for 5 minutes and literally watch smoke bellow off the table in rolling fumes. And this stuff, you'll watch it settle, and then everything around you in the whole shop is covered in orange.
Right.
It can't be good for your lungs.
Right.
I can't believe it would be.
Right. Yeah.
If you walk away from something coughing.
Yeah. It's probably a good indicator.
Yeah.
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 Well, Chris, I think we've talked a lot about, how different tables work, everything. Is there anything else you think people just really should know about out there? Or can you think of anything else that we haven't touched on that might be beneficial?
Yeah, sure. So the last thing that I'd leave you with is understand what you're trying. When you're making this decision between water table or a downdraft system, or even between technologies, laser cutting or plasma cutting, all that type of stuff, get samples. Get samples from your supplier, honestly. And I can get you some samples cut on a water table or cut on a downdraft system.
Yeah.
And there's notable differences. And when you hand that to an operations guy, and he looks at those two parts and he says, well, this one's going to take me 5 minutes of grinding to prep.
Right.
This one's going to take me 30 seconds to prep.
Right.
That's the game.
Yeah.
That's it. Those 5 minutes add up very quickly. All of a sudden, you're employing 2 more people just to grind the parts.
Right.
Because you have your water table set too low.
Yep.
And now you're not even collecting the dust anyways.
Yeah.
And you're dealing with bad parts.
Right.
And I think the water table back in the day made sense. But now we've gotten all these other variables solved to the point that we're looking for other things. And the next variable is sticking with downdraft.
Yeah, and efficiency, and just trying to, the guys you're paying to weld, you want them to be welding. Yeah. The guys, you know what I mean? You don't want to have them messing with parts more than they have to. You want them to do the job you're paying them to do. And I get it. Uptime, productive time is, helping people make money. So that's what you guys want to do. That's what we want to do. We want to help people be productive, and we want them to be in the healthiest and safest environment that they can. And, that's what we're trying to do on this podcast, is help people understand what's a good decision for them to be healthy. I think that's what you guys are doing over at AKS too, trying to create a good, healthy shop environment for people and, produce that. And, well, thanks for coming on. I really appreciate it. Everyone who's listening, if you would, you can check us out on social media. You can subscribe, check us out there. AKS, you guys have a lot of social media. We got all that stuff too. Yeah. Yep. So find us all on Twitter, LinkedIn, YouTube, all of that. Chris is glad to talk to you. I'm glad to talk to you. If you have any questions, You can check us out there. And until next time, you guys stay healthy, stay safe, and we'll be looking forward to talking to you again.
You got it. Thank you for having me on.
Yep, thanks for coming.
Thanks for listening to the Dusty Jobs podcast. Breathe better, work safer.